peacetime atomic energy is creating a new world of job opportunity in the fields of science and industry. Therefore, every possible safeguard has been devised to protect the workers. On reporting for work at a site where radioactivity is used, employees receive a film badge and a pocket ionization chamber. Both are devices for measuring radiation, but not in the same manner. Thus, one can act as a check against the other. No matter what their task, as long as they work with or near materials that are capable of emitting radiation, the employees will wear this film badge and pocket ionization chamber called a pencil meter. These are individual monitors for radiation exposure. There are others which cannot be worn because of their size. When the workday is over, the pencils and film badges are returned. Each is numbered for identification, and the badge carries the employee's picture. This is a primary step in the matter of protection for the individual worker. The ionization pencils are checked daily to determine to what extent the wearer has been exposed to gamma radiation. This is to assure that the worker is not receiving more radiation than is permissible. A double check on the effectiveness of radiation shielding, time limits, and other precautions. First, the charge in the pencil is noted, then it is discharged by this manometer, then recharged for use once more. Film badges usually need to be examined only once a week or so. The sensitive film records, by a process of darkening, the amount of beta and gamma radiation to which it has been subjected. The film is developed, then checked with a densitometer, and the readings are carefully noted and filed. If by chance readings show that the exposure to radiation has accumulated up to the maximum permissible level allowable, the employee will be sent to a non-radiation area. Another precaution is the use of special monitors which warn those who may have inadvertently picked up contamination. This man is alerted by a ringing bell activated by a radiation detector to the fact that he has picked up some radioactive contamination. He immediately uses the small counter called a frisker to locate the contaminated area. He starts with the top of his head and will cover his entire body in the process. In this particular instance, he finds the hot spot on the hip of his working coveralls. His next step is to remove the garment so it can be further monitored and then properly decontaminated. Before taking off his coveralls, he removes his badge and ionization pencil. These, as we know, will later be checked as an additional protection. The containers are marked to indicate which ones are for hot clothing. The coveralls are put in the bin for decontamination, and the wearer will now thoroughly wash himself to remove any other contamination. A final check before leaving the installation will be made by this hand and foot counter. The employee turns the tester to 0 and steps on the machine. The counter will be activated by any radioactive materials present on his hands and feet. The tolerance board alongside will give him his margin of safety. By comparing the readings on the machine with the notations on the blackboard, the worker can determine if he is radioactively clean. The contaminated coveralls will now be monitored to determine exactly how much radioactive materials they contain. This is a beta-gamma counter designed by the Health Physics Department of an atomic laboratory. If it indicates the garment is too hot, it will be destroyed instead of laundered. The laundry contains the finest of modern equipment. Clothing sent here may be either hot or cold, contaminated or uncontaminated. The hot clothing gets a special decontamination washing and is remonitored after it is washed and before it is ironed and sent out for reuse. Under no circumstance is a garment allowed to be worn if it has any contamination. These checks, rechecks, and various tests and safety measures all combine to make the atomic energy field one of the safest in which to work. One of the effects of exposure to excessive radiation is a change in the number of blood cells in a person's system. An important safeguard is the testing of blood samples of personnel who are exposed to radiation above a certain specified level. The blood samples are collected in small pipettes which are placed into an agitator prior to the testing. The operator carefully makes the count, and exact records are kept of the result. These records are consulted at regular periods to determine whether or not there has been any significant change in the blood picture. This is an extremely valuable check on possible radiation exposure. All cuts and abrasions are carefully examined and then monitored for radiation if the worker is from an area in which contamination is possible. This man has cut his hand on a broken bottle which contained low-level radioactive material. The nurse cleanses the wound before a health physics monitor tests it with a radiation counter. The result is negative, and the nurse will bind the wound without any special treatment. Some employees in the atomic energy field are exposed, from time to time, to radium dust. Radon, a decay product of radium, might be inhaled by the worker. Therefore, their breath is checked at regular intervals. A radiochemist captures a sample of breath in a special flask. As long as the concentration of radon is not allowed to build up, the workers are presumably safe. The testing process is a comparatively simple one. A measured amount of hydrogen is added to the breath sample and attached to a radon ionization counter. This will give an exact reading on the degree of concentration in the worker's breath. This precision instrument is another of the many devices developed by the Atomic Energy Commission and its industrial and university contractors to maintain a careful system of checks and balances on the safety of all people engaged in this newest of sciences. We are rapidly approaching the time when atomic energy will be a daily part of our lives. Therefore, this advanced research ensures the future welfare of all of us. The result of the test is printed automatically on a moving tape, which then becomes part of the records. All areas where hot products are being handled are continuously monitored by a health physics specialist. This is standard operating procedure in all laboratories and installations. A variety of instruments are used. One of the commonest is this counter known as a QT Pi, which measures gamma and beta radiation. Radiation survey instruments must be kept at extremely high levels of accuracy to be of maximum value to the health physics program that protects the atomic worker. Therefore, these instruments are checked at regular intervals. This is often done by means of a calibration trolley, which consists of a lead shield in which a radiation source is housed, a movable stand on which the instrument is mounted, and a table with a small telescope. The method of testing and adjusting is simple. The QT Pi is placed on the stand. A reading is taken by the operator, and if an adjustment is necessary, it is made by the assistant. Now the instrument is tested at greater distances from the radioactive source, using the trolley as a yardstick. The source is always lowered into the lead shield before the assistant approaches the instrument being tested. Again, we see how a double check on the speed and range of radiation protects those who are working in the atomic energy field. Scientists pursue a never-ending search for new and better methods of detecting even the smallest trace of radioactivity in areas where men or women work. Results from all of the tests and safeguards you have seen, as well as many more, are made part of a permanent health record which is kept right up to date. Carefully and efficiently filed and cataloged, these records are an immediate source of information on any worker. But these countless files record more than facts about atomic workers. Figuratively, they represent the intensive program which has so successfully protected personnel in this new age of atomic energy. All this is resulting in the greatest possible safety for those who are unfolding for you the magic of the atom.